Hi everybody, and welcome to part 2 for our medical geography unit, looking at people and the environment and how diseases impact various ecosystems. In our last presentation, part 1, we had this list of questions, just repeating them here for you just to remind you about what our focus is. And we're going to move on from there and develop some of these ideas. So as we continue with some context, we're looking at life expectancy here. So one of the things that we want to think about for life expectancy is the impact for people. And as we're looking at the slide here, we've got some information about women. Living longer than men, the average is 4 years longer. In Russia, it's approximately 14 more years than what men do. We can also look at this within other populations as well, looking at animal species if there's a difference in gender with them as well. But we're going to use the people example for this one. So here's a population pyramid, and a population pyramid takes and divides up population by gender, male and female, and then it puts them into age cohorts, and that information is listed on the y-axis of our graph that's here. And what I want you to do as you're looking at this one for Russia is I want you to key in on those age cohorts, the 50 to 54 up to the 65 to 69. And then if you go over and look at the right side of the population pyramid, which is telling us the population of females, you can see what those percentages are for those cohorts, 3.2, 4.14, 3.4, etc. And then we can compare them to the population percentage for male, 2.8, 3.3, 2.9, and 2.1. And you can see that there are more women than men, so this supports then the idea that women live longer than men. So we want to think about what kind of an impact that has in regards to health, quality of life. We also want to consider other components, in particular when we're looking at the human population, and think about ethnicity. And we want to kind of question what role does it have in disease prevention, what role might it have in diffusion. And we also want to be able to define ethnicity. So if we define ethnicity as cultural traits, common histories, landscapes, shared language, etc., we can then have a cohort or a demographic group that we look at by ethnicity. So the graphic that we have here is showing us adults aged 18 and older who have arthritis, and it's been divided by race or ethnicity and gender. And this is data from 2009 to 2011, and it comes from a number of different sources, okay? So Centers of Disease Control and Prevention is one of them. Now, they have on here by gender, female are the darker red, males are the lighter pink color in regards to our nice little bar graph that's there. And if you just take a look at that, you can see that there are some disparities in regards to incidence. You can see that more women than men generally are impacted by arthritis, and you can see that there's a difference in percentages. So if we look at the population of non-Hispanic Black, right, you can see that the disparity between female and male, 27% of women, 18% of men. 9% difference. Why do we have that 9% difference within that particular group? We can also not just compare within a group, we can compare between groups. So if we look at where the arrows are on the right-hand side of the graph, you can see that we have non-Hispanic Asian women compared to non-Hispanic multiple race, and we go from 2.9%, so 13, to 32, almost a 20% difference. Why is that? So one of the things that we want to be looking at from the medical geography perspective is thinking about why do we have disparities in prevalence in particular populations. Now, we also can think about not just disparities within a population and within particular groups of people, but we can also come at it from a regional perspective as well. So why do we have contrast between regions? Whether those regions are within a state, like what are the regions of Wisconsin, or whether those regions are on a more global scale. Now, one of the ways that we look at this is something with world systems theory, which is mostly an economic perspective, but nonetheless it has bearing here because world systems theory talks about core, semi-core, and periphery. And mostly it's focused on economics. It's looking at labor and resources and money and power. And if you have more resources and you have more power, as the core nations tend to do, that means that you have a better chance of putting in place both public health policies that are beneficial, as well as environmental policies that are beneficial to people as well as to the natural environment. Whereas if you have fewer resources, the chances of you doing that are less, right? So it sets up a contrast between the core, the semi-core, or the semi-periphery, and the periphery nations. And if we look at it from an economic perspective, as we see on this screen, we can see what it looks like. What is the spatial distribution based on those definitions of core, semi-periphery, and periphery, right? So hopefully, as you're looking at this map, you're identifying where are the core countries? Why are they there? Where are the periphery countries? Why are the periphery countries the periphery countries? And what about the semi-periphery? And what kind of impacts those designations may have on public health and environmental health for a particular location, whether it's a singular state like the Democratic Republic of Congo, whether we're looking at a region, the Sahara of Africa, or whether we're looking at a hemisphere, the Eastern Hemisphere. We also want to think about demographics. And demographics we can put into a lot of subcategories, no matter whether we're talking about plants, animals, or people. So obviously we can do it by gender, we can do it by age. If we're talking about people, we can talk about literacy, we can think about ethnicity, we can think about mortality rates for everything. We can think about access, for example, to the internet or no access to the internet or cell phones. All of those things are categories that we look at demographically. And depending upon what ecosystem we look at, whether we're looking at a tall grass prairie, for example, or whether we're looking at bighorn sheep, or whether we're looking at the pallid sturgeon, we can look at the various demographics within that particular population. As we look at the demographics within that particular population, we can also start to look at what are some differences within those populations. So in geographic terms, some of the things we use, or a term that we use, is idiographic and nomothetic. So if they're nomothetic, things that are the same. So what are the similarities? If we're looking at things that are idiographic, what are the differences? And why are those similarities and why are those differences there? So the map that we've got right here is showing us heart disease, and the map on the top is showing us for men, the map on the bottom is showing us for women. And I've circled South America because we see a big difference in that for those two particular genders. This is an area of demographics. Okay, we're looking at it from a gender perspective. It's the same disease, but we're looking at what kind of incidence rates we have based on gender. We can also look at incidence rates based not just on gender, but we could also look at it based on age. And we can do this for our plants and animals as well as we can do it for people. So this one is showing us an H1N1 case outbreak in the United States back in 2009. And I put a green arrow pointing at the April to November 14th, 2009 period. But you can see that that middle category, which is the 18 to 64-year-olds, if we go and look at the dates on the bottom on the x-axis, we can see that that age cohort increased through time significantly more than what the other cohorts did. So it was that population that was more impacted than the other populations were. They all were impacted, but it was that age group that we see the most in, right? We can also compare diseases as well, whether that disease is within an animal population or whether it's in with the human population. So here they talk about the swine flu, which is the normal flu, okay, or the H1N1 flu. Why is the H1N1 flu disproportionately impacting people ages 25 to 49, but not in the other group, right? So we can get all kinds of statistics and look at things this way. The other thing we want to start to think about, and we'll define some of these terms coming up, is whether or not a disease is a communicable disease or a non-communicable disease. And that makes a difference as well when we're thinking about Where is the origin? What is the source area of that disease? How many people within that source area have the disease? What kind of routes or transmissibility does it have? So at the end of part 2, one of the things that I want you to think about looking at this particular map, which is showing us non-communicable diseases from 2010, is which countries or areas or regions have fewer non-communicable diseases and which area has more communicable or has more non-communicable diseases. And you may want to come back and look at this map after we have defined non-communicable as well as communicable in our next presentation. So here we are at the end of part 2. We're going to continue with part 3 when you're ready, and I hope everything's going well for you.